All right, we are continuing with 5b. This is still 5b. Now we're talking about multiplying monomials times binomials. So it's a monomial expression times a binomial expression, two terms. Binomial just means that you have a term and you have two different terms joined by addition or subtraction. We got to do this a little different than we did last time because now we are going to be distributing. There's two types of distributing that we're going to be doing. We have single distribution and double distribution. And for double distribution, I'm going to use the box method. You can use that. Up to you. There's multiple ways to do it. So I'm just going to get started with number 15, and let's see how this works. So we have 10 times 5 square root of 5, or square root of 10 times 5 square root of 5. So you multiply the coefficients first. So if there are coefficients, you multiply those first, so that's 5. And then times the square root, and now you're going to multiply underneath the square root. So 10 times 5 is 50. And there we go. There's the first monomial times a monomial. And now we're going to do subtracting. It's going to come down, and we'll have 1 times, so the 1 times 2, we'll just get in the habit of that. You don't have to do it because 1 times 2 is 2, so that 2 really would come down. And then times the square root of 10 times 2 is 20. So at this point now, we have multiplied it out, the monomial times the binomial. Now we need to simplify each individual term. So I am solely looking at 5 square root of 50 and simplifying that. So a square root of 50, we can break that down. 5 is a prime number, 5 times 2. And it's a square root, so we're looking for pairs. So we have a pair of 5s. So the 5 is going to come out, come down. Pair of 5s, that's 5 times 5 is 25. Square root of 25 is 5. Square root of 2. All right. And then we have, I'm going to come over here. So 5 times 5 is 25, square root of 2. And now we have to also simplify 2 times the square root of 20. So that 2 is going to come down. Square root of 20 is 2 times 10, 2 times 5. Oh no, 4 times 5. What am I doing? 2 times 2, so we have 3 2s and a 5. So a pair of 2s comes out. 2 times 2 is 4, and square root of 4 is 2. That's why I wrote a 2. And then the 2 times 5 is left over. That's going to stay underneath the square root. So that is going to become, so the subtraction comes down. It's going to come down. 2 times 2 is 4, square root of 10. The square root of 2 and the square root of 10 are not like terms, so we cannot put them together, and that will be your final answer then. All right, let's take a look at number 16. So here we actually have a binomial times a binomial. You can do 8 times 3, 8 times the square root of 10, negative 10, or square root of 10 times 3, negative square root of 10 times negative 10. You can do it like that, and some of you may have learned that way with the FOIL. But then there's also like a little bit more of an organizer, multiplying it out. And this kind of comes from factoring. So I'm going to put 8 and a negative square root of 10 in the top of this Punnett Square, and 3 and a negative square root of 10 on the bottom. We're going to multiply them out. 3 times 10, or 3 times 8 is 24. 3 times a negative square root of 10 is a negative 3 square root of 10. Negative square root of 10 times 8 is a negative 8 square root of 10. And negative 10 times, or square root of negative 10 times a negative square root of 10 is a positive square root of 100. All right, we have like terms here. A negative 8 square root of 10 and a negative 3 square root of 10. Those are like terms. I'm going to rewrite these all out. So we have a 24 that's going to come out. And we have what I highlighted in pink, negative 8 square roots of 10, and I'm subtracting 3 more. That's going to be a negative 11 square roots of 10. And then the bottom right there, that can be simplified. Square root of 100 is 10. So we're going to add 10. Well, let's check to see if we have like terms, and we sure do. Our like terms are 24 and 10. We're going to add those together to 34 minus 11 square root of 10. And the square root of 10 cannot be simplified, so that is your final answer. All right, let's take a look at number 17. So I'm going to do the Punnett Square again. A little bit easier to do the organizer, especially with the coefficients and the radicals, I think. Square root of 6 and a positive square root of 2. So that's a plus. Multiply the first two out. 6 square root of 6 times the square root of 6. That's a lot of 6 square root of 36. Square root of 6 times a negative 6 square root of 2. That's going to be a negative 6 square root of 12. And then 6 square root of 6 times a positive square root of 2 is 6 square root of 12. And the last one, negative 6 times, that'll be a negative 6 square root of 4. All right. We have like terms again. We have 6 square roots of 12, and we're subtracting 6 square roots of 12. That actually works out really nice. That's going to add up to 0 or subtract to 0, whichever way you want to look at it. Other things we have a square root of 36. That's going to be 6. So that's going to be 6 times 6. So that's going to come out as 36. And then we have one other thing we can simplify. Square root of 4 is 2. So negative 6 times 2 is negative 12. So 36 minus 12, that's all we're left with, which is 24, and that's our final answer. Awesome. All right, number 18. This one got me in high school. I remember getting it wrong on a test. So you have a binomial squared. Squared means times itself. So what is itself? Well, it's 4 minus square root of 5 times 4 minus square root of 5. Exponent just means how many of those are multiplied together of whatever the base is. All right, let's do the Punnett Square. So we have 4 minus square root of 5, 4 minus square root of 5. We're going to multiply 4 times 4, negative 4 square root of 5, negative 5 square root of 5 times 4 is a negative 4 square root of 5, and a negative times negative is a positive, and that's going to be a positive 25. Like terms, a lot of times they are diagonal of each other if there are any. If we put those, well, those are like terms. We also got to simplify the square root of 25, and 16 is already simplified. So let's see what we got here. We have 16. We have a negative 4 square root of 5, and we're subtracting 4 square roots of 5. That's a negative 8 square roots of 5. And then square root of 25 is 5. So we got a plus 5. Well, 16 plus 5 those are like terms. And we have minus 8 square root of 5. Cool. All right, moving on. We have number 19. Now we're introducing some variables. Don't worry about the variables. We can do that. So if we multiply the first two monomial times this monomial, we have the square root. 12 times 3 is 36. They're both underneath the square root, so we're going to keep them there. K times k, there's two k's that are multiplied together, so that's k squared. Bring the subtraction down, because this is a positive over here, so it's going to stay subtraction. Now we have square root. We have a positive, or subtract 2 is going to come down. 1 times 2 is 2. We have the square root. 3 times 15 is 45. And k to the first times k squared is k to the third. All right, after you multiply, always look to simplify. So I'm going to look at the first square root. Square root of 36 is 6, and the square root of k squared is k. All right, and then we have the 2 comes down. This is, remember, it's always multiplication outside of the square root, unless it states something different. 45, square root of 45 can be broke down into 9 and 5, 3 and 3. So you have a pair of 3s. So that's going to come out. K to the third. Remember, it's a square root, so you're thinking how many pairs can you take out of 3? And that's 1. Or you could just do this. K, K, you have a pair with a K left over. There'll be a 5 left over and a K. All right, let's clean this up. So we have 6K minus 2 times 3 is 6K, square root of 5K. So we cannot it's very, very tempting to just subtract those, but you have to remember order of operations, multiplication first. So we'd have to look at individually, is 6k, is that the same like term as 6k square root of 5k? No, because the 6k, the first one, does not have a square root of 5k, so we cannot simplify those. Therefore, this is your final answer. All right, number 20. Let's do a Punnett Square with a binomial. You don't have to. You can do something similar to what we did on number 19, but I think it's going to be a little easier to focus. Remember, this is positive. So we have square root of x squared, a negative square root of 8x, square root of 2x, and the negative square root of 16. All right, we have simplifying. We have square root of x squared is x. We do not have, as of right now, like terms diagonally. But what we do have, what I can see is we can probably simplify this 8. And we can with a pair of 2's. So that's going to come out as a negative 2, for the negatives from out front, square root of 2x. So this is going to become, I'm just going to rewrite what do we have here. We have, this is going to become negative 2 square root of 2x, and we're going to add 2x, or square root of 2x. And then lastly, we have the square root of 16 with negative on the outside. That's going to become negative 4, so minus 4. So let's clean up what we have here. We have x. We do have like terms. We have a negative 2 square roots of 2x, and we're adding 1 square root of 2x. So that's going to be a negative 1 square root of 2x, or a negative square root of 2x, minus 4. And that is your final answer. All right, find the area of the perimeter of a rectangle shown on the left. Area just means length times width of a rectangle. So I'm actually just going to break this down into, I'm going to make it Punnett Square. So you're multiplying them together. So 4 minus square root of 6, 7 square root of 6, and a positive square root of 3. So we have 28 square root of 6, negative 7 square root of 36, 4 square root of 3, and negative square root of 18. Let's look what we can simplify. We have 28. I'm just going to rewrite them all out. Minus 7 square root of 36, plus 4 square root of 3, minus 8 square root of 18. So can we simplify square root of 6? No, that's 3 and 2. Can we simplify square root of 36? Yes. So we have 28 square root of 6 minus, this is 7. Square root of 36 is 6. 7 times 6 is 42. Can we simplify the square root of 3? No. Can we simplify the square root of 18? Yes. Let's break that down. We have 9 and 2, 3 and 3. So that becomes a 3 on the outside, square root of 2. And now I'm comparing every single square root of 6, not just a coefficient or a constant, square root of 3, square root of 2. No like terms. Nothing square root wise that's the same, so that is your final answer. Cool. Hopefully this helps you.